Hi and welcome back to my channel. This week's problem is an interesting one. It's trying to find the area of this circle, but there's a few key things about this circle. Now it's touching the sides of a square on two sides of the circle, the top and the left, and this square has a side length of 10. Now we've also got a sector here, ACH, that is going from the top left of the square and then touching it's not a side, but touching a length that goes from the middle of the right hand side of the square to the bottom left of that square. Okay, as you can see, now the circle is touching two sides of the sector. Can you work out the area of the blue circle? And if you were able to work it out and your solution is different to mine, please put it down in the comments below. If you're not already, subscribe to the channel because I upload a new problem solving video every week at 5 p.m, Monday 5 p.m. Now, if you want to have a go at this problem yourself, pause the video now, because otherwise I'm going to show you my solution in 3, 2, 1. Okay, now the first thing that I wanted to do is to start labeling these sides. So I labeled C to D5 and D to E5 because they are half of the side of the square. Now the next thing I wanted to do is to label this angle here as theta, and I'm going to put a right angle at the point E. We know it's going to be a right angle, but just to be clear, I've put that there. Now, I then know, because it's a triangle, that this angle at D is going to be 90 minus the theta. From there, what I can do is I can work out the angle at CDH by doing 180, because we've got angles on a straight line, minus 90 minus theta, and that gives me 90 plus theta. So this angle at D has to be 90 plus theta. From there, what I can do is I know that this radius, it's singular, radius is 10 because that is the width of your square. It is the radius of the sector, so it has to be 10. Next thing I wanted to do is work out this angle here, alpha, and I chose specifically that angle because I want to work out the angle HCD, but I can't do that until I've worked out this angle at alpha. I can work out the angle at alpha with sine rule because that angle alpha is opposite the 5 and we've got 90 plus theta opposite the 10. Okay. So by sine rule, sine alpha over 5 is equal to sine 90 plus theta over 10. Right, now the problem, or a problem I've got here, is trying to work out what sine 90 plus theta is. Now I could work out the exact angles, but actually I don't need to, and I'm going to look at the sine curve here. And I'm going to make it a bit bigger so that you can see it if you're watching on your phone or any other small devices. I've isolated just the sine curve from 0 to 180. Now the reason for that is because theta is an acute angle, so if I do 90 plus theta or 90 minus theta, it's not going to be below 0 or above 180. Okay, so 90 plus theta on my sine curve, let's say theta is that distance, it's arbitrary, it doesn't really matter, but it's that distance. Okay, that will go up to some height on the sine curve, and if I also take away theta from 90, so do theta less than 90, that will go up as well to a point on the sine curve, which those 2 points, because of the symmetry of the sine curve, will be the same point, will give me the same output. And so because we know that theta here is acute, sine 90 plus theta will be equal to sine 90 minus theta. Sine 90 plus theta is equal to sine 90 minus theta. Okay, or will at least give us the same value in terms of output. Right, now what I need to know at this point is the value of sine 90 minus theta, and I can do that using my triangle DEF. So sine is equal to opposite over hypotenuse. So if I look at my triangle DEF, opposite is the 10, and the hypotenuse, well, I haven't worked that out yet, but I can work that out because I've got the other two sides, so I can use Pythagoras. So 10 squared plus 5 squared and square root it will give us 5 root 5. That is therefore going to be the length d to f, the hypotenuse, which is what we need. So from there, I can substitute in for sine 90 minus theta. The opposite is 10 over 5 root 5, which is the hypotenuse. So I've got this fraction, which is a little bit messy at the moment. It's 10 over 5 root 5 divided by 10. Now, if I divide that by 10, I'm going to get 1 over 5 root 5. Multiply both sides by 5 here, I'm going to get 5 over 5 root 5. Now, interestingly, again, looking at the triangle DEF, sine of theta is also equal to 5 over 5 root 5, opposite over hypotenuse. Now, because alpha and theta are both acute angles, we have that sine alpha is equal to sine theta, and because, as I say, they're both acute angles, alpha must be equal to theta. So from there, what I'm going to do is replace the alpha on the diagram with theta. Just like that. Now, I've then got two angles in the triangle CDH. So I'm going to work out the third angle, there you go, by doing 180 minus the two angles, 90 plus theta and theta. That gives me an answer of DCH being 90 minus 2 theta. Put that on the diagram. And because we've got a right angle at ACE, I do 90 minus 2 theta, gives me the other angle as being 2 theta. So BCI as being 2 theta. From there, what I'm going to do is I'm going to start considering the radii of the circle. So O stands for the origin of the circle, or the center of the circle. I'm going to draw on my two radii. I'm going to introduce right angles there. We know that a radius meets a tangent at 90 degrees. And I'm also going to introduce this line from O to C. Now, because OBC and OIC are congruent triangles, they are going to split that angle 2 theta into theta and theta. I'm also going to introduce this radius because, again, the circle is tangent to the side of the square. That then means from A to B is a length of r, and from B to C is therefore a length of 10 minus r. Now, the final piece of this puzzle really is identifying that triangle OBC is similar, because it's got the same angles, to triangle DEF. That then means that the sides of those triangles, the corresponding sides, will be in the same ratio. And so we get that r over 10 minus r is equal to 5 over 10. And then all we need to do is start rearranging this to solve for r. So 10r by cross multiplying is equal to 50 minus 5r, and therefore 15r is equal to 50 by adding 5r to both sides. Dividing by 15, we get that r is equal to 10 over 3, and then we can very easily find the blue area, or the area of the blue circle, by using pi r squared. Pi times by 10 over 3 squared gives us a final answer of 100 over 9 pi centimeters squared. If you enjoyed this problem and my solution, please drop a like on the video. If you're not already, please do consider subscribing to the channel. Thank you so much for watching. Please help us if you can get to 1,000 subscribers. I would very much appreciate that. And as I say, thank you for watching. Have a great week, everybody, and I will see you next week for another video. Till then, bye-bye.